Hey guys, welcome to our file analysis workshop. I'm Arin, I'm one of the officers, and
Hi, I'm Yunfan. I'm another officer who's going to be presenting today.
And I'm Matt. I will also be presenting. All right, so the basics of what bytes are. This is something you have to understand before we can talk about file analysis properly. So if you've taken CS33, you'll have a pretty in-depth understanding of what bytes are. But we'll just go over the basics for this workshop in case you haven't. So this is the stuff that you'll need to know for this workshop. You know, this is not very comprehensive. Basically, computers can only understand numbers. You probably heard that in CS31. So everything has to be represented by numbers in some way, whether it's images, text, videos, documents, anything you have on a computer has to have some way of being represented as a number. And basically bytes are numbers from 0 to 255. And that's what makes up those numbers that represent files. Generally, they are represented as a hexadecimal number. Hexadecimal is another word for the number system called base 16. So that base 16, it has 16 characters that can represent numbers. So the number system that we commonly use, which is sometimes referred to as decimal, is base 10 because it has 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hexadecimal uses those same ones, but it also uses A, B, C, D, E, and F to mean 10 through 15. So if you wanted the number 12 in hexadecimal, that would just be C. If you wanted a number larger than 15, then you'd start and you'd add a 1 to the left of your first number, just like you do in decimal. It's basically the same as decimal counting, except you have A through F at the end of 9. And like in decimal, if you have a place, you have like a tens place and a hundreds place and so on. And you probably learned this in like second grade where, if you have a 3 in the hundreds place, that means it's 300 plus a 4 in the tens place is 40 plus a 6 in the ones place is 6. You sum those together. It's the same thing in hexadecimal when you're reading it, except it's a 16s place instead of a tens place, but the ones place is the same. There are some calculators online. If you don't want to be bothered with that, you can just look up hexadecimal to decimal, calculator or conversion or something, and you'll find something online. And hex numbers will sometimes start with a 0x at the beginning to indicate that they are in fact hexadecimal numbers. Because if you just saw 1, 5, it doesn't have any hex specific digits, A through F. So it might be difficult to know whether it's a decimal number or whether it's a hexadecimal number. So sometimes they'll start with 0x, sometimes they won't. But if you see 0x, you know for sure it's hexadecimal. Next slide, please. We're not going to spend too much time on this slide. This is a useful chart that you might need for some of the challenges. It talks about ASCII. ASCII is a way of representing characters as bytes. And you can see on the chart there the decimal value, the hexadecimal value, the octal, you can ignore that for the purposes of this workshop, and then what the actual character is. So in the middle column, the second entry you can see is a capital A that has the decimal value of 65, the hexadecimal value of 0x41. So that chart will possibly be a useful reference for some of the challenges we're going to go over. This is a very common way that text is encoded as numbers so that computers can store and manipulate it. You can also, again, look up like hexadecimal to ASCII converter or online. Those can also work if you don't want to calculate things by hand. You do have to be careful not to mix up what's decimal and what's hexadecimal. So make sure you're looking at the right column if you do use the chart. Most files that have a hidden flag in them, it'll often be encoded in ASCII. So it's a useful thing to look out for. Next slide, please. All right, so finally, let's talk about what files are. Basically, a file is a container that a computer stores a bunch of bytes in. The computer usually doesn't care what the file contents are, until you try and open it or send the file to a program. Basically, it just cares that, hey, there's a container here with a bunch of bytes, and I'm going to keep those bytes together. Now, files can also have metadata, which is information about the information contained in the file. It's not the actual file content itself. You have a text document. The actual text that's in the document is the information within the file, the actual data. The metadata would be extra information like who owns the file, who created the file, when the file was last edited, and that sort of information will be useful later, which we'll get to in a couple slides. Next slide, please. All right, so a file format is a standard way of encoding information so that it can be stored as a file. So everything has to have some sort of file format. Text, images, and documents, videos, all those have different types of file formats that there are to encode those different types of media. The file extension is one hint you can have as to what the file format is. So the file extension is usually the last part of a file name, like .txt, .jpeg, .doc, .mp4, stuff like that. Usually the computer doesn't care what the file extension is. Windows kind of does, Linux doesn't very much, but you can manually change the file extension and it won't actually change the content of the file, just what the file appears to be on the outside. Yeah, next slide, please.
All right, so now that we've gone through all the basics of like hex and bytes and files, you might be wondering, like, so what? How does this tie back to cybersecurity? So in the end, what we are presenting about today is called file analysis. So file analysis is basically taking everything you know about a file, extensions, metadata, some other things that we'll talk about later, and trying to use that to get as much information as you can out of the file. So a lot of the times, files won't actually be exactly as they appear. There might be a flag hidden inside of them. For example, either in the metadata, maybe the file's broken and you have to try to fix it so you can actually view it. There's a lot of different ways that files can hide data, and we are going to go over some of the ways that you can find that information from these files. All right, next slide. So the first way that files can hide information is through something called magic bytes. And so basically, as Matt was talking about, a file format describes how the computer encodes information as bytes so it can be stored in the file, but actually the computer doesn't care what the file extension is, if it's a .txt, a .jpeg, PNG, whatever. They actually identify what type of file it is through something called a magic bytes. So what magic bytes, or sometimes magic numbers, are they're basically specific byte sequences that are used by the computer to identify a specific file format. So on the right there, you can see a lot of the common magic bytes, good reference for the challenges later. So for example, if you have a JPEG file, the first two magic bytes are going to be like FFD8 and it ends with FFD9, or .png, .pdf, all of them have a slightly different sequence. And if you go in and mess with these bytes in any way, like if you change them to a different number, like if I changed the .png to 8850, then the file's contents will be unreadable by the computer because it's not going to know what kind of file it is and how to open it. So next slide. So as I was saying, by changing the magic bytes, you can make it so the computer is unable to read the file, but humans can still read it. And if you can figure out what's wrong with the file, like maybe the magic bytes have changed from a 9 to an 8, like I said earlier, and fix that, then you can actually make the file readable again. So additionally, since some formats actually end with magic bytes as well as starting with them, such as JPEG, you can actually append extra data afterwards too that will actually be contained within the file, but you won't actually be able to see it when you open the image. So both of these methods of hiding data and pictures are pretty easy to figure out if you just examine the file's contents in the file's raw contents in bytes. And there's a lot of tools that you can use to do this. Two of them that come to mind are HexEdit on Linux or HXD on Windows. You can also just Google online. There's plenty of resources that you can use to view the contents of a file. All right, and then Arin now will show a quick demo for file analysis with Linux.
Yeah, so if you want to follow along, we have the links here, and also we sent them to our Discord and posted them in other places, so you can grab that if you want. But yeah, so, oh, before I start, does anyone have any questions? Like if you want, you can just put them in the chat and we'll try our best to answer them. If not, I will just continue with our demo. All right, so there's two things that they're kind of cover sort of the same general material. I have some files on, I have some files on my computer, and let me just ls so I can see what they are. So I have what.png, which is what we're gonna look at. And so I'm gonna try to open it. And as you can see, it's telling me that I can't open it, which, you know, kind of sucks. I kind of want to see why it's not letting me open this this file. So I'm going to use a command called file, and this will tell me some basic information about this file, and maybe will point me in the right direction as to why I can't open it. And it turns out when I do run this command, it tells me that it's a text file, which is probably why I can't open it. It's not a PNG, the computer got confused. So what we need to do is we need to change the name of this file. We need to change its extension from PNG to TXT. So I'm just gonna go what.png to what.txt. And then, yeah, as you can see, the preview shows that I can open it, but I'll just cat it so you can see it here too, that we do have a flag and we can open the file, and that's that. Yeah. I will show you another way that we can find out about a file, and yeah. So I have the second file in my in this folder called huh.png. I'm gonna open it, and it tells me I can't open it, which kind of sucks. Yufa talked about something called magic bytes. So I have this online hex editor open, and I'm just going to drop this file in here. Aha, so you can see with these first 2 bytes, this tells me that this is actually a zip file, which is also why I can't open it. It's not a PNG. So I'm just going to rename it again with the move command. So let's see, huh.png becomes huh.zip. And then I can use the unzip command on this file, and then okay, so as you can see, I now have a folder called huh. So I'm just gonna go in there and then see what's in here. It's a text file, and I'm just gonna open this text file, and there's the flag. So now we know that sometimes our files can lie to us with their titles, and so we have to find other ways to identify them and, you know, just kind of get to the bottom of all of that. Yeah, so that was our demo. Does anyone have any questions, or else I'm just gonna continue talking? Alrighty. Okay, so another cool, I guess, concept within the world of file analysis is file carving. And this is where files are kind of in like an odd place on your computer. And so in order to gain access and to be able to open it, and, you know, we'd need to sort of carve it out. And the examples for where this could be like, maybe there's a file embedded inside another file. If you had like a pointer to a file, but then you made the pointer point to somewhere else, so your file is just kind of floating in your computer, or if you have like corrupted directories, which is the case for, I think, like criminals who want to delete like confiscated, like not confiscated, like weird incriminating evidence. And then this is how like government officials would like go back in and then find those files. And yeah, so the way we would want to, say, carve out a file that's embedded in other files is to use the commands binwalk and dd. We gave you instructions to download binwalk, so you guys should have access to that. Binwalk will show you if there's any file sort of embedded within a file, and dd will help you carve it out.
Awesome. So as a kind of an extra bonus bit, we'll talk a little bit about steganography. So steganography is kind of like file analysis's best friend. They're not exactly the same, but they're very closely related. I guess like a sister then. So basically steganography is hiding information inside of like a picture, an audio file, a PDF, just something like that, in a way that doesn't make it immediately obvious that any information is even being transmitted a lot of the time. So For example, you could make an audio file play notes that actually spell out a flag, or you could hide text inside of an image that doesn't show up when you open the image. So you have to do something special to it to be able to find the information that it's hiding. So one really useful tool for this is called StegSolve. StegSolve is a tool that analyzes the file structure, which helps figure out if the file's hiding anything from you. So what a couple of things that StegSolve can do is it allows you to view each bitplane on its own. It allows you to apply color filters really quickly in case the flag is just like, maybe you need to apply a red filter over the whole photo to be able to see it, or do colored level adjustments in order to find information. So StegSolve is a kind of more complicated or like involved tool. So Steg Online is a great online version of this. It has less functionality than StegSolve does, but it's really easy to use. You can just drag the image in and it lets you manipulate the colors, the bit planes, etc. And we're going to do a quick wink wink. It might be very helpful when you're trying to solve the challenges later. Are there any questions about steganography? Awesome. Okay, so just before we end, I know a lot of people who came to our fall GM probably did some of these commands, and if you didn't, don't worry. They're super easy to learn in Google, and you can ask our officers about them when we're working on the problems. But these are really useful Linux commands that you might use while you're solving our challenges. I'll just go through them really quickly. ls is used to list all of the files within the directory. A directory is basically like a folder. I think most people have worked with like creating a folder on your computer and putting files inside of it. So ls lists all the files that are inside your current directory. cd is a command. You enter a path and then you can move into and out of directories. Like if you want to go into a folder, out of a folder, you would use cd. Cat and then a file name is used to read the contents of a file. So for example, maybe you want to cat the README and then it'll give you some hints about the challenge like you did in the GM if you came. So man and then a command is a command that shows you the command info page. So it's got a command that shows you info about the command. And you can do that if you're wondering like what flags can I add into the command or like what does it do? MV, you saw Arin use earlier. You can use it to change the file name. Just like MV, I think the syntax is MV and then like the original file name and then the new one. I could be wrong, but I think that's right. And then Vim, Nano, Emacs, etc. are all text editors that you can use to edit your files. So those are the like basic commands. When there's a couple of more commands like file, telling you what file type it is, strings, prints readable strings, binwalk and dd, Arin went over. They're really useful for like file carving and other types of file analysis because it helps you find embedded files or extract part of a file. grep searches for a string within a longer string, and hexdump prints the bytes of a file, which is useful for maybe examining if there's a flag hidden in there somewhere. So basically there are a lot of commands, and I don't think anyone here knows all of them or like how to use them correctly. So just Google and ask the officers or other people if you need help. Lots of tools exist on the web to solve these challenges. There's no one right way to do most of them. So just have fun, play around with the different commands and the different tools that we've shown you. And yeah, if anyone has any questions, let us know. All right, so we have about 9 challenges, I think, written of different parts of file analysis. And if you go to acmcyber.com/challenges, I'm pretty sure you can access them now. And you get points for each one that you solve. And if you want the attendance code, it's "that's so meta," as written on the slides right here.